This lesson is evaluating numerical expressions involving exponents. Exponents are a shortcut for repeated multiplication. So instead of writing 6 times 6 like this, we can write it as 6 to the second power. 6 is the base and 2 is the exponent. So for number 1 here, we want to write it using exponential notation. It's repeated 5s, so 5 is my base. And I'm multiplying 5 by itself for a total of 3 times, so that's my exponent. So this is exponential notation. The next one says evaluate. Well, 7 to the 4th means repeated 7s multiplied by itself for a total of 4 times. So it's really 7 times 7 times 7 times 7. But the word evaluate in math means that we're just going to multiply that sucker out and get it done. So first we're going to do 7 times 7, and that's 49. So that takes care of these two 7s. And we'll multiply 49 times 7 for 343. And that takes care of another 7. And then 343 times the last 7 here is, carry the 2, 0, carry the 3, 21, 24, for a total of, after I multiply, 2, 4, 0, 1. So that's how I evaluated that. Now we're going to evaluate these other expressions. Now we have to be very careful for this, so when you write this down in your book, I want you to keep referring to it when you do the My Math Lab assignment, because it will save you. This first one, number 3, means negative 6 times 6. So that means to multiply the 6's first, which is 36, and then negate. So it becomes a negative 36. Now in this one, see how the negative 3 is in like a little shell there? That means I'm going to multiply negative 3 by itself. Everything in the little shell gets multiplied by itself, and that becomes 9. Now, so when you see the little shell, you're going to write down whatever number is in that little shell and multiply it. In fact, notice how I kept using the little shells to help me. This next one, number 5, you have a variable here. So I'm going to write an automatic shell and fill in what the variable is equal to. And again, we have the shell thing going on. So negative 10 times negative 10 written in the shell will be 100. The next one, 4x squared, is a little tricky because we haven't done a whole lot of order of operations yet. But here's the deal. Again, I create the shell, put in the 3 for the x. Now, if I think about it, 3 squared really means 3 times 3. And this 4 in front of the x squared really means I'm going to multiply. So that thing that's all together means everything is under multiplication. And now I can just go ahead and multiply. 4 times 3 is 12. Times 3 is 36. Or I can do something with order of operations that says I need to do the exponents first. So 3 squared is 3 times 3, which is 9, and 4 times 9 also equals 36, so it also works that way. Math is really great. If you follow the rules, you should get the same answer whatever way you do it. Now, we're going to look at some rules of exponents using whole numbers. So, we're going to look at rules for multiplying and dividing whole number exponents for right now. So here we have 5 squared times 5 to the 3rd. Well, that means 5 times 5 is 5 squared. 5 times 5 times 5 is 5 to the third, so we really have a total of 5 5s multiplied together, so 5 to the fifth. So when you multiply numbers with the same base, you can add the exponents. For the next one, let's look at dividing. 5 to the fourth really means 5 multiplied by itself for a total of 4 times. And then 5 to the third means 5 times 5 times 5. So now what I can do is I can divide out 3 of these 5's, because 5 divided by 5 is just the number 1. So I'm not canceling them, I'm dividing them out. They become 1. And I get 5 to the first, which is 5. So when you divide numbers of the same base, you just subtract the exponents. Now let's look at raising a power to a power. It seems a little confusing, but it really isn't. This really means the nutshell, 5 squared times 5 squared times 5 squared. And what do you do when you have the same base? You add your exponents, so we'll get 5 to the sixth. But instead of having to do that time after time after time, you can raise the power to a power and multiply your exponents. So let's look at a couple of examples. We'll do number 8 first because it's easier than number 7. So write it in simplest form. So this is 3 to the third really means 3 times 3 times 3. And 3 to the eighth really means 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. One more. So I really have 3 to the 11th. But I didn't have to write out all that shenanigans. I could have just added my exponents and got 3 to the 11th. But if you are getting into the habit of visualizing what it means, it's so much more helpful to you when you have to do it. So when I write number 7 in simplest exponential form, I'm raising a power to a power, so I multiply my exponents. I get 3 to the fourth. The denominator is really 3 to the first. When there's no number in the exponent, because math people are lazy, they don't want to write the 1. They know that you know it's a 1, so they don't want to write it. You just have it there so that you know now I can subtract my exponents and get 3 to the third. Think, 3 to the fourth means 3 times 3 times 3 times 3. 3 to the first means 3. I divide out. 3 divided by 3 is 1. 3 times 3 times 3 is 3 to the third. Now in my math lab, they might, if you type in 3 to the third, they might say, although this answer is equivalent, we would like you to evaluate it, or something like that. In that case, they want you to multiply all the 3's out. So it's helpful to write down what it means. 3 times 3 is 9, times 3 is 27. So when the exponent, I would say in general, is 4 or less, I would actually physically write out, multiply out that product. Now you are ready to do the My Math Lab assignment with this lesson. Ask your instructor any questions that you have. Good luck.